I'm coming in auto, ma'am. I'm attending on my phone.
Okay, okay. So I've started recording. Okay. So the moment we say we are asking for who will undergo SN1, it means we are looking for a carbon with a positive charge. A carbocation should be stable. So we are trying to understand the first compound. The bromine is connected to this carbon, so this is alpha. And this alpha carbon is in turn connected to 2. So won't it become secondary aprameya?
Yes, ma'am.
So this is secondary. The next compound is the cyclic structure with no double bond, but instead it has got a CH2Br. So now the carbon carrying the functional group is alpha. That is connected to only one more. So it is a primary. This is secondary. This is primary. Try to understand, okay? From whatever you have understood, try to make an understanding of the concept once again. Fine? In today's class, I'll just keep discussing the answers. So try to understand and try to check whether you have understood the concepts well. So the alpha carbon, I've taken the second option. Alpha carbon is containing the bromine, or the carbon containing the bromine becomes the alpha carbon, which in turn is connected to one more. So it is primary. The next one is where the bromine is directly connected to a cyclohexyl ring. So this time, this is alpha carbon, which carries the functional group. It is connected to two more. So this becomes secondary. The last one is a aryl bromide. And we know that haloarenes do not undergo the substitution for 4 reasons that we saw: unstable carbocation, partial double bond character, shorter bond, and repulsion between the electron density of benzene and the incoming nucleophile. The reaction does not happen. So the least reactive of all will be the aryl halide, that is the bromobenzene. Out of the others, there is no tertiary. Correct, ma? Aprameya? There is no tertiary. Is
Yes,
there any
ma'am.
benzylic or allylic? To be an allylic, it should be an open chain structure. What is a benzylic? Benzylic is C6H5, CH2 positive charge. C6H5, CH2 positive charge. So is there a probable place where I can generate a benzylic carbocation?
No, ma'am.
No. Okay, the only compound in which there is a benzene is this, but that happens to be an aryl, and we know that that is the slowest. So we are looking for allylic. What is an allylic? Allylic is where the halogen is connected to an sp3 carbon, which in turn is connected to sp2 carbon of an aliphatic system. So once the chlorine goes, the sp3 carbon will have a positive charge, which will be resonance stabilized. So once the allylic carbocation is stable, the reaction moves through the SN1. So the question is now, to have an allylic, there has to be a double bond. Out of the three, which has got a double bond?
A.
The first one. Okay, I'll give you one more option. Okay, so if there is a benzylic, please do remember. One final time I'm telling you. Benzylic, allylic, and tertiary carbocation, if it is possible. If in a substitution reaction, the carbocations can be benzylic, allylic, or tertiary, then it will take the SN1 pathway. Okay. Tell me, out of these two, which is allylic and which is non-allylic? Out of these two, which is allylic, which is not allylic?
The first one's allylic
First one is allylic. And why is the second one not allylic?
because there's no double bond in,
On what do you want?
in
I
the.
wanted this system, a positive charge. The
Yes, ma'am.
double bond should not be far away. So if, and it should be close by. Supposing the bromine leaves, it will produce a positive charge. The double bond comes here and saturates, stabilizes that. Or technically, what is the definition of an allylic? Allylic will be something where the halogen is attached to an sp3 carbon, which in turn is connected to sp2 carbon. Now, how to identify an sp2 carbon? If there is a double bond on the carbon, that must be sp2 in nature. So look at this. This is the halogen is held onto an sp3, but that is not connected to sp2. These both are sp3 only. So it is not an allylic system. So the option will be the first one.
Yes, ma'am. Thanks.
Is it clear, children?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay, next one. Try to understand, have a deeper understanding. Okay. And by the Sunday, please generate those 4 charts. Learn them, write the chart, close the chart, rewrite the chart without looking at it. Whatever mistakes you are doing, if you do 2 to 3 times Aprameya, you will not forget the reactions at all.
Yes, ma'am.
Is it okay? Keep telling yourself. Keep saying about it. When an alkyl halide is treated with PCl, let us say when an alcohol is treated with ZnCl2HCl, OH is replaced by a Cl. Keep saying and writing. You will not forget. Okay. Draw the structures of the major monohalo product in each case. Now, the difference between the two, you see, similarity between the two is there is a double bond and there is a double bond. Will addition reaction take place on benzene, children? Can addition reaction take place on benzene? Is it possible? No, because benzene ring is aromatic, highly conjugated system. So if I want to add, let us say HBr, okay, let us do that H and Br. What will happen? The conjugation of the double bond is broken. The aromatic nature of the benzene ring is broken, destroyed. So benzene never undergoes addition reaction directly. Rajesh, is that fine?
Yes, ma'am.
Okay. So in both the cases, the double bond is there. There is a double bond, there is a double bond. And these double bonds will not be undergoing addition reaction. So don't consider. Now I have given HBr to this, but there is no mention of UV light. Okay, or peroxide. There is no mention of peroxide. That means this is a regular, what is it, Prameya? Markovnikov rule. Okay, Markovnikov addition, which says that out of the 2 carbons, the positive part goes to that carbon which has got more hydrogens. So where will it go?
CH2.
CH2. And the negative part goes to that carbon which has got less number of hydrogens. So the benzene ring will stay as such with all its double bonds. The CH will receive the bromine and the double bond is saturated to single bond because of addition of the HBr across. Okay. Next one. The cyclohexene is reacted with bromine in the presence of UV light. Now UV light, supposing the reaction had said that simply bromine in CCl4 or CS2, anything, these are solvents only. I'm trying to add bromine to this cyclohexene. There is a lot of difference between the two sets of reagent. The UV light allows the reaction to happen by free radical halogenation, whereas bromine in CCl4CS2 is a simple addition reaction across a double bond. So the 2 bromine atoms will get added to the carbons containing the double bond. Any doubt in this? This is a simple addition reaction. But since you're given UV light, it goes via radical. So that means it is a substitution. It is a substitution. So it has got nothing to do with the double bond. Clear? Clear?
Yes, ma'am.
So where will the substitution happen? The question is, where will the substitution happen? Again, like this case, we told benzylic, allylic, tertiary, then secondary, then primary. Carbocation stability is similar to the radical stability. So we should look for whether there is any benzylic carbon or allylic carbon or tertiary carbon. So is there any benzylic, allylic or tertiary? This compound, does it have an benzylic, allylic, or tertiary carbon?
It has an allylic.
Allylic. It doesn't have a benzylic. Benzylic, again, for you people to just remember it, must be a CH2 positive charge. Maybe something like you have a halogen. So if the halogen goes, you get a benzylic carbocation. I told you benzylic radicals are also stable. So there is no carbon here, which is benzylic. What is benzylic? An sp3 carbon, which in turn is connected to sp2 of a benzene ring. So there is nothing like that. This compound is not having a benzene ring. So what is allylic here? Let us remove this and see. What is allylic? An sp3 carbon, which in turn is connected to sp2 carbon. So that means these are what? Are these allylic, children?
Yes, ma'am.
Can these be termed? This is an sp3, which in turn is connected to a doubly bonded carbon, which is sp2. So it is allylic. This is allylic, even this is allylic. That means the halogen gets added to this position. That means the product is not going to disturb the double bond. The bromine appears on the allylic position. Any doubt in this, children? Both of you?
No, ma'am.
Okay. Okay, you can put it up or down. That's up to you. You can put the bromine here also, nothing wrong. Okay, so Grignard should be prepared under anhydrous condition. Should be prepared and should be used also, both the ways. A simple statement, R MgBr, right? Being the R part being negatively charged and MgBr part being positively charged. The on exposure to water, it grabs the proton. So H plus of the water goes to the R minus, OH minus. All this you don't have to write. You simply write that the Grignard gets hydrolyzed in the presence of water to form the alkane. Through this, please try to remember whatever we have done. And I am emphasizing the first lesson is very, very important to understand the subsequent lesson. Similarly, second lesson is important for third lesson. So you cannot think, okay, this lesson is over. Let me focus from the second lesson. No. First lesson, you have to learn thoroughly. Okay. So though it says it reacts with water to form alkane, you write the word that it gets hydrolyzed in the presence of water to form the alkane. Okay, next one. Alkyl halide gives alcohol with KOH, but in presence of alcoholic KOH, alkenes are formed. Alkyl halides. Okay, alkyl halide. So I'm going to take one alkyl halide. CH3, CH2Cl on treatment with aqueous KOH is giving the corresponding alcohol. So isn't it a nucleophilic substitution, children, where the OH minus is replacing the Cl minus?
Yes, ma'am.
Whereas if you treat it with alcoholic KOH, then this combination is a base. And what will base do? The base will come to a free site, relatively free site, take a proton and put the electron pair in to the compound and will ask the leaving group to go out. That means you are going to get a CH2 double bond CH2 plus you are going to get a HCl out. Is it okay? In fact, you get actually water and KCl because who is picking the H's? The OH minus. So H plus and OH minus will form the water. The Cl minus which is thrown out will combine with K plus to form KCl and the alkene is generated. So alcoholic KOH combination acts as a base and leads to elimination than substitution. Whereas an aqueous KOH suggests the substitution reaction. Is that clear? Very, very important points to remember, children.
Yes, ma'am.
Okay. Aprameya, clear?
Yes, ma'am.
Okay. Next one. Which of the following is an allylic? Allylic, remember, I told you allylic means the functional group should be connected to an sp3 which in turn is connected to sp2 carbon. That means a carbon having double bond. So functional group is connected to a carbon, which in turn is connected to a carbon, which is actually having double bonds. Okay, so we have to think about it. Here, the bromine is the functional group and it is directly connected to sp2 carbon. Again, I told you how to identify sp2 carbon. sp2 carbon is the one where you have a double bond. Okay, just for you to have a recap of all that. This only you are wanting, Lima. I write so much here. I have a doubt, okay, whether you will get anything useful. But anyway, how do you identify if you have carbon bonded to 4 different groups, then it is automatically sp3. If a carbon has a double bond and 2 single bonds, then it is sp2. If a carbon has a triple bond and a single bond, then it is sp. Or if a carbon has 2 double bonds on it, then also it is sp. So these are the 3 classes. So how do you identify an sp2? Supposing we have this, the bromine is connected to a carbon which has got double bond. So this carbon has got a double bond and 2 single bonds. That means it must be sp2. Clear?
Yes, ma'am.
Okay. Now, so the first one is not. Actually, first one is what? Tell me. There is a special name for that. If the halogen is directly connected to a doubly bonded carbon, then also there is a special name. What is the special name, children? Is it not vinylic? When an halogen is directly connected to an sp2 carbon, then it will be called as vinylic. Clear?
Yes, ma'am.
If the halogen is connected to sp2 carbon of a benzene, if the halogen is connected, alcohol is connected, halogen is connected, etc., to an sp2 carbon of a benzene ring, then it is said to be aryl halide. Aryl halide and vinylic have similarities. In the very first class, we had a discussion about this. Next one. Out of chlorobenzene and 2,4,6 trinitrochlorobenzene, which is more reactive towards nucleophilic substitution? We were remembering that the chlorobenzene, there are 4 reasons for the reaction not to happen. The lone pair is in resonance. There will be a partial double bond character. So it's very hard to break the double bond. And sp2 carbon bond becomes shorter, possible repulsion between the nucleophile and the electron density of the benzene, all that will not allow the reaction to happen. But the moment you introduce nitro group, that two, how many? 2, 4 and 6. What will the nitro group do? Very recently we did this. Nitro groups are electron
Withdrawing
group. What do they do? By withdrawing electron density, they reduce the electron density of the benzene. Thus, a nucleophile is able to get easily attracted to it. The nitro group, 3 nitro groups will withdraw electrons and cause an electron deficiency on the benzene ring, which will allow the nucleophile to visit it more successfully. Clear? Or when a nucleophile attacks a benzene, you are going to get a positive charge, basically. Okay, carbanion, sorry. You are going to get, because the nucleophile is attacking, this negative charge comes over the orthocarbon. So if there is an electron withdrawing nitro group, the negative charge, the pi electrons is withdrawn by the nitro group. So it stabilizes the carbanion. Okay, the nitro group is stabilizing the carbanion. Also, the nitro group, because they are electron withdrawing groups, increases the positive charge density. Okay, so because of the electron withdrawing nature of the nitro group, this is very, very short. You can't write only this much. Because of the electron withdrawing nature of the nitro group, the benzene ring is electron deficient. Therefore, the nucleophile gets attracted. When a nucleophile attacks, the benzene ring gives rise to a carbanion. Nitro group stabilizes that carbanion. Okay, any one of the ways you can write. Which isomer of C4H9Cl has the lowest boiling point? The lowest will be where you have got more branching. And the highest will be there where you have got least branching. Correct, children?
Yes, ma'am.
Okay. Coming to the next one. Which of the following contains an sp2 halide? Which of the following will contain an sp2 halide? sp2. That means you should have a double bond. This should be allylic, vinylic, alkyl, or benzyl.
Allylic and
Allylic, just now we saw
oh,
Prameya. Just now we saw it's this, na?
yes, ma'am.
An sp3 carbon. Halogen is connected to sp3 carbon, which in turn is connected to sp2. Whereas they are asking a direct carbon with sp2 holding the halogen. Which is that? If you want to write Prameya,
Sorry.
benzylic is this. Benzylic is this. CH2Br. So what is the nature of this carbon? Benzylic is this. CH2Br. Isn't it sp3? Yes.
Yes, ma'am.
Okay, write an example of allylic. CH2, double bond CH, CH2, halogen. That's first one, allylic. Alkyl. Alkyl is simply CH3, CH2, Cl. Benzylic. Benzylic is C6H5CH2. Keep telling that, Aprameya, you will not forget. C6H5CH2. C6H5CH2 is allylic. You have to keep, it should become familiar on your tongue. Vinylic. When a doubly bonded carbon has a halogen. What is aryl? Aryl is when the doubly bonded carbon is benzene, is part of benzene ring. Then this is aryl. This is vinyl. Okay, this is benzyl. This is simply alkyl. And this is only allyl. Now, which one has got sp2? Which one has got the carbon containing halogen is sp2? Which is that case?
Aryl and vinyl. Right.
Aryl and vinyl.
Yeah.
But you don't have aryl in the list. So which
Yes.
will be your answer?
D.
Vinyl. Yes, ma? So Rajesh, clear?
Yes, ma'am.
Okay. Answer number 2, ma. Rajesh. Which of the two is an example of allylic halide? The first one or the second one?
And the second one?
The second one. Again, look at the slide and check. Halogen is connected to sp2 carbon directly. Halogen is connected to sp2 directly of a non-aromatic system, vinylic. Halogen is connected to sp2 of a benzene ring, aryl. Halogen is connected to sp3, which in turn is connected to sp2, benzylic. Halogen is connected to an sp3, which is not having any double bonds throughout. Simply an alkane. Then it is alkyl. Halogen is connected to sp3, which in turn is connected to sp2. It is allyl.
So the first one.
Okay, the first one is sp3 connected to sp2 of a non-aromatic system. So this
Yes, ma'am.
must be allyl. And the second one, what does it tell me then? Look into the categories and see.
Now to vinyl.
It's a vinyl. Clear, ma?
Yes, ma'am. I got
This is
confused
vinylic.
between like is it directly connected to an sp2 or
Ah,
connected to an sp3 with an sp2?
yeah. Now see here. You have to remember this is an alkyl halide. It is very usual. Chlorobutane, bromobutane, etc., etc. The case is between only these. Vinyl is where the halogen is connected to sp2 of an aliphatic system. If halogen is connected to sp2 of an aromatic system, or it is directly connected to benzene, okay, then it is aryl. If the halogen is connected to sp3 but is later on connected to sp2 of benzene, then benzyl. Halogen is connected to sp3, which is in turn connected to sp2 of a aliphatic system, then it is an allyl. Okay, next one. Which of the two is allylic, vinylic?
The second one.
The second one is vinylic, and the first one is, it's a repetition, correct? It is
Yes,
a
ma'am.
repetition. Yeah. Okay, next one. Out of the two, which is benzylic? Define the benzylic. The halogen is connected to an sp3 carbon, which in turn is connected to sp2 of a benzene ring. Which is that then?
The first one.
The first one. Yes, Aprameya, any problem in this?
No, ma'am.
Okay, though there are two chlorines, each one of them is connected to sp3 only, no? Which in turn is connected to sp2 of a benzene ring. Clear?
Yes, ma'am.
This will behave like an alkyl. If it is not allyl, if it is not vinyl, if it is not benzyl, and if it is not aryl, then it will become alkyl. Forget about the benzene interfering in the reaction. Nothing. This will be independently working as an alkyl halide. Okay, next one. Write the IUPAC name of. Okay. So there are functional groups. There is a double bond, there is a halogen. Okay. So which one will be given priority? Double bond or the double bond? So you will start numbering from here. 1, 2, 3, 4, and 5. Okay. If the double bond and the halogen were receiving the same numbers, okay, then probably we can think about it. Otherwise, the double bond should be given the priority. So it's a write the name of the simple structure without looking at the other things. What will be the name?
Pent, ma'am.
Pent, pent, 1 or 2 ene. Where is the double bond?
I'm pent
Is
2
it?
in now.
So this is pent, 2 ene. And where are the other things now? Include the other things. What are the other things?
Ma'am, one halogen bromine and methyl group.
Yeah. And which one will be called out first, bromine or the methyl, Aprameya? Both are on the same numbers, whatever it be. Which one will be called out first, bromine or the methyl?
We should call the bromine, right? So,
Yeah, alphabetically. No matter whether the number is higher or lower, whatever is left out will be substituents and you will call it in the alphabetical order. So it will be 4 bromo, okay, 4 methyl, pent 2 ene. Okay, the next one. 1 bromo, 4 chlorobutene, and they want you to write the structure. Whenever I told you to write the structure, you start from the last. So up to this, butene, catch hold of the parent. Like pent2ene was the parent. Others were substituents. So catch hold. So butene, there are 4 carbons. Double bond is present on the second carbon. Then on the first carbon, there is a bromo. On the fourth carbon, there is a chloro. Is that fine?
Yes, ma'am.
Okay. Similarly, you can write about the others. Prop 1-ene. Okay, we'll go to the next one. Prop 1-ene. And on the third carbon, there is a bromo. On the second carbon, there is a methyl. So this is bromo and this is a methyl. This is prop 1-ene. 1, 2, 3. So third position bromine, second position methyl. Okay. 2 bromopentane. So 1, 2, 3, 4, 5. Pent, 1 pentane. So 2 bromo. This is the bromine. That's it. Always start writing the structure from the last. First you do the pentane and then introduce the other substituents. Okay. Again, I'm leaving the IUPAC system, IUPAC nomenclature, and going to maybe the reactions. Okay, this folder I'll send you, and you can also see this. You can also work on this. Okay, the next one. What is this? What do you recollect out of AlCl3, Cl2? Did you prepare the chart of reactions, ma'am?
Yes, I did.
Where did you see this AlCl3,
Friedel
Cl2?
alkyl.
Friedel-Crafts. It's not Friedel-Crafts because Friedel-Crafts is about alkylation and acylation. This is simply halogenation.
Okay, sorry.
This is, you don't call it Friedel-Crafts. Halogenation is not called Friedel-Crafts.
So
Even though you use
I got
AlCl3, you don't call it Friedel-Crafts. You will simply say it is halogenation. So the species that attacks benzene in the following. It is it's halogenation. What kind of mechanism is it? Is it it is an electrophilic substitution.
Electrophilic.
Yeah. Last year you have studied about the mechanism. So what does AlCl3 do on the chlorine molecule? This is a Lewis acid. It wants electron pair. It's an electron pair acceptor. So what does it do? It goes and cleaves open the chlorine molecule to break out a Cl minus for itself. So what will it form? It will form AlCl4 minus and a Cl plus. So it's the Cl plus which attacks. So D must be the answer. Next one. Which of the following has got highest boiling point? Higher the molar mass, higher the boiling point. And out of fluorine, because C2H5 is common in all the four, the molar masses increase from fluorine to chlorine to bromine to iodine. So highest molar masses of iodine. Right. So which one will have highest boiling point?
D,
Boiling
man.
point is directly proportional to the molar mass. So it should be D. Okay, next one. Boiling points of alkyl halides decreases in the order. Same. Ri is greater than Rbr, Rcl, Rf. The assertion is true. Van der Waals forces decrease with increase in the size of halogen. Does it decrease or increase? Van der Waals
It
forces.
increases, ma'am.
It will increase. Okay, that means this reason is false. So assertion is true and reason is false. Next one. Para-dichlorobenzene has higher melting point. What is the advantage of having para-dichloro over others? Para-dichloro has higher melting point. In melting point trend, we basically see the symmetry. We basically look at the symmetry. So is the para-isomer not more symmetric?
Yes, ma'am.
Para-dichloro is more symmetric. Therefore, it will be better fit. If you want to think about who is compactly placed, then being para-isomer is better than being ortho or meta-isomer. Okay, you cannot expect the compact arrangement with two chlorines protruding on the same side. No, children?
Yes, ma'am.
Yes, okay. So this has got greater symmetrical structure. Therefore, it is, when it sets as a solid, it sets in a compact manner. So its melting point is high. Okay. Then alkyl halides, though polar, are immiscible with water. What was the concept? You were telling last week also, Prajesh was telling this. What was the concept? Alkyl halides are not soluble. Immiscible means not soluble in water. Why?
because of minus I effect, or am I right?
No. Repeat, Aprameya, you have to repeat. Re, do. Okay. The Rx interaction with the water is poor, is weaker than the water-water interaction or the alkyl halide interaction. So the energy which is given out during alkyl halide water interaction is not enough to break open water water interaction or alkyl halide interaction. Do you remember this? Are you getting it?
Can you
What
like
have-
explain again, ma'am? A bit simpler.
See, why is NaCl dissolving so easily with water? Because it forms Na plus aqueous and Cl minus aqueous, na?
Yes, ma'am.
Okay, have you not learned that if you want to melt it, is it easy to melt NaCl?
No.
No, you cannot separate the sodium ion and the chloride ion, correct? So easily because of very strong interionic forces, na? The
Yes,
sodium
ma'am.
cation is strongly held. So when it is interacting with water, what will happen? The sodium ion is surrounded by many water molecules. So there is ion water interaction. In fact, precisely ion dipole attraction, ion dipole. Chloride is also negatively charged, so ion dipole. But here, the alkyl halide water interaction is it's like compensation. Okay. Say, supposing you are coming to school on a Sunday for some school work. What will you say? Supposing annual day is scheduled on Sunday. What will you say? Since because you came to school on a Sunday, which was a holiday, will you not demand for a holiday on the working day? Does that happen or not? No, it
Yes,
doesn't
ma'am.
happen. See, the energy here, whatever energy is coming out, so when sodium ion is surrounded by so many water molecules, Na plus is surrounded by water. Which part of the water? The electronegative part of the water. So when so many water molecules surround it, what will happen? So many bonds are created. Whenever a bond is created, energy is given out. So it's a compensation. The energy given out in this part will go and break open the attractive force between water and water and Na plus and Cl minus ion. So the energy given out in the final stages, after dissolving, energy given out here should be enough to break water-water interaction and Na plus and Cl minus attraction. Same thing we expect here also. The forces between Rx and water should be giving enough energy to go and break the water-water and Rx bond. But that's not sufficient. The bond here is a weaker bond. So less energy is given out. These bonds are not broken up. Aprameya, are you able to remember?
Yes, ma'am.
Yeah. What about you, Ma?
Yes, ma'am.
Yeah. So this we did. And when we did the Lucas test, was this not the reason for which the alkyl halide produced is? I think I have to spend some more time over this particular topic. Okay. Because see, it is the ease. If you start being comfortable with one organic lesson, progressively it will become easier. Otherwise, what will happen? Next will be a pile up of the concepts. You will not be comfortable with it. So we will spend one or two classes. I don't mind spending some special classes also for this. Just not to delay the progress of the other lessons. I don't want to, no. So we can have look at this, read this once. Go and read this, please, both of you.
Yes, ma'am.
It's slightly soluble. The haloalkanes are slightly soluble, or you can almost say that it is immiscible. The energy is required to overcome the attraction between haloalkane molecules. You need RX bond, RX physical bond to break. Water physical bond to break. To break this, energy should be given. And who is supposed to give the energy? The RX interacts with water and produces energy. That energy is supposed to go and break these interactions. And then only RX water bond will become established. Since this is so weak, very less energy is given out. It will not break water or RX. How can you expect RX to interact with water? Lesser energy is released when new attractions are set up between haloalkane and the water molecules. And these are not strong. As a result, it's not able to overcome the attractive force between water and alkyl halide and alkyl halide. Is it clear?
Yes, ma'am.
Yes, Aprameya?
Yes, ma'am.
Yeah. Ma, please, both of you dig in this lesson first. சரியா? Let us be comfortable. Once you get the knack of being comfortable with one organic lesson, in upcoming organic lesson, it is more reactions, more concepts. That's all. Is it okay? Okay.
Yes,
When
ma'am.
you
Yes,
read
ma'am.
the textbook, what you can do is you can maybe not get confused with this section. This section you don't read, I'm saying. The nucleophilic substitution, because it's so much. The enantiomerase, that is SN1. I believe SN1, SN2 is completely clear to you, right?
Yeah.
SN1, SN2, enantiomer, racemic mixture, inversion, all those definitions, etc. You are very clear. So skip these pages and read the rest of it very, very finely. Where did it go? This is also that one only. Up to here you read. Where? Up to this also don't read. Because I've taught you everything, and during the question paper discussion, we will go through each and every term. What is meant by chirality? What is enantiomer? What is racemic function? We will again do. Okay. So retention, all this don't do. So your duty will be to ignore all this. Say, I'm making your work simpler. So up to this, you are not going to do. Okay, from that substitution topic till here. Don't do. Read only the rest of the lesson. Okay, spend some time, children. Once you get comfortable with the first lesson, the progressive lessons will be easier. Remember. Okay, word by word you write. Word by word you read. Explain why the dipole moment of chlorobenzene is lower than that of cyclohexyl chloride. Now, this is conceptual. Okay, and a very important concept. See, the dipole moment depends upon what? The dipole moment is calculated by doing what? Say, supposing I've got a HBr. How do you calculate the dipole moment? You see how much positive charge, how much negative charge, measure the distance between the two, and take the charge, the quantity of either the positive or the negative charge, multiply it with the distance separating them, correct?
Yes, ma'am.
Okay. So either the whatever amount of positive charge is there, that much of negative charge will be there. So take any one of the charges without the sign, that into the distance separating the two. So now the question is, why chlorobenzene? Look at this. We'll compare it with the cyclohexyl chloride on the next page. See, in a cyclohexyl chloride, this is cyclohexyl chloride. Number one, is it not an sp3 carbon? So should this bond
Yes,
not be
ma'am.
longer bond? Is this not a longer bond?
Yes, ma'am.
Okay, second thing. In the chlorobenzene, the bond becomes a shorter bond because it is sp2. This is a longer bond. Not only that, due to resonance, okay, here the chlorine is electronegative, carbon is electropositive. But there is a resonance. And because of resonance, what will happen? the carbon-chlorine bond will become a double bond. It becomes even more shorter. Plus the chlorine acquires a positive charge now. Because out of 3 lone pairs, we have taken 1. So where is the charge separation? Q is missing, no? The electronegativity is lost. Chlorine's electronegativity is lost, isn't it?
Yes, ma'am.
So Q is missing, that the electronegativity of chlorine is gone. Plus also because of the sp2 nature of the carbon and double bond due to resonance, the bond length decreases. So Q decreases, D decreases. If both of them decrease, the dipole moment has to decrease. Aprameya, is it clear?
Yes, ma'am.
The same concept we will discuss in the next lesson for cyclohexyl alcohol
But can you
and
go to the
phenol.
previous?
Yeah, I'll do that. See, the same concept will be for cyclohexyl alcohol and phenol. There is no resonance. There are lone pairs, but there is no double bond to take it. But there is lone pair and there are double bonds to show conjugation. So the carbon-oxygen bond becomes double bond. It becomes shorter bond. Oxygen has got positive charge. So Q is not there. Oxygen is not enough electronegative. The distance between the two also has decreased because of the double bond. Polarity decreases, dipole moment decreases. Both the lessons we will see this. In chlorobenzene, cyclohexyl chloride, in phenol and cyclohexyl alcohol. Same concept it is. Is it clear?
Yes, ma'am.
Yes,
Yes,
ma'am.
Aprameya?
Yes, ma'am.
Okay,
Yes, ma'am.
revisit the concepts. Okay, and please take time to do it. This Sunday, I'll interact with all 4 individually.
Yes, ma'am.
Okay, right. Okay. N-butyl bromide has a higher boiling point than tertiary butyl bromide.
Because it's a linear.
Avladam. So more van der Waal, more surface area, more van der Waal forces of attraction. You add. Okay, more the linear structure, more the surface area, more the van der Waal forces of attraction. Clear?
Yes, ma'am.
Okay, next. Which of the following molecule has a chiral center? Chiral center is one which has 4 different substituents. What happened? Aprameya left and joined.
Illa, ma'am. I think Rajesh.
Rajesh has. Supposing you have got a CH3 here. You have got a chlorine. You have got a bromine. You have got an OH. Then this carbon is chiral. Whereas this carbon is not chiral because this has got 3 identical groups. Even if it were CH2Cl, this carbon has got 2 identical groups, hydrogen, and chlorine, and it is connected to this whole system. So a chiral carbon is the one which has got 4 different substituents. This carbon has got 4 different ones, but this carbon is not. So this is chiral and that is not chiral. Like that, you have to search for which of the following molecule has a chiral center correctly labeled. Check.
Ma'am, is it B?
Is it B?
Yeah.
Yeah, it is B. Okay, what is the structure of the first one? Isn't it CH3? C
It
connected
has
to
2
hydrogen.
methyl groups, ma'am, the first
Yeah,
one.
it has got 2 metal groups, correct. Okay, so first one is not. The second one is
It
CH3,
has
C,
CH2H.
H, Cl, then CH2Br. So this is chiral and these are others are not. Okay, the next one has got 2 identical groups. See, it is
CH2OH.
it's CH2 bonded to OH, which in turn is connected to CH, in turn OH, and further it is connected to CH2OH. So it is not chiral. None of them are chiral because this carbon has got 2 identical hydrogens. This also has got 2 identical hydrogens. The central carbon has got 2 identical CH2OH. The last one has got 2 identical methyl and 2 bromines. So it will also not. Okay, in the lesson, Landa, if you look at the collection of questions, There will be very few. It's a very small but very deeper lesson. Next, upcoming lessons are very lengthy. None of for concepts, sir. So get comfortable with this. Okay. Consider the following compounds. So let me copy the compounds and see the questions later. This is CH2Cl, and the last one is an aryl halide. Reactivity decreases. Aryl halides are not so reactive. The correct order of reactivity towards SN2. SN2 is given by a sterically less hindered, primary more than secondary, more than tertiary. So which one will be the fastest to react, ma'am? 1, 2, or 3? What is the nature of this halogen? This carbon is connected to 2 more carbons. Isn't it a secondary?
Secondary one.
And the carbon containing halogen, this is the one, alpha, which is connected to only 1 more.
Yes,
So
ma'am.
this is primary, and this as such is secondary, but it is very, very difficult to break the bond because of 4 reasons. sp2 carbon, resonance making the double bond. Okay. Then repulsion between the leaving group, the nucleophile, and the phenyl carbocation being unstable. So even SN2, SN1 will not be possible. So whenever you look at chlorobenzene, you have to have a angry face towards it. It will not undergo nucleophilic substitution. Got it? And how to ease that? How to ease that angry face? Connect nitro groups. Connect more nitro groups. Yes, Aprameya? Correct more nitro
Yes.
groups to make the cleavage easy. Connect even more. So much so that even water will come and displace. Knock it off. Connect 3 nitro groups. 1 here, 1 here, and 1 here. Okay. So this is the least reactive will be this. 1 is least reactive. This is faster, much faster, and the fastest. So again, remember, whenever you look at chlorobenzene, bromobenzene, look at it with a scary face. It doesn't allow the nucleophilic substitution to go on. Connect such emotions, children. It will help you. Something funny, something, always. When you read, you try to connect some funny incidents. Maybe a talk which we had in a class. Okay. Maybe a punchline, something that will help you to recollect. So in the previous case, remember, nucleophilic substitution on halobenzene is nearly impossible unless you use, if at all you want to do 623 Kelvin, 300 atm pressure. So number 2 will be the fastest, then number 1, and then number 3. Is it okay?
Yes, ma'am.
So it will be this. The next one. In the reaction, C6H5Br Mg. What will Mg do? It will just go and sit between the two.
Yes.
Remember. So it will become C6H5 MgBr. Then you are treating it with water. Water is a very, very poisonous substance here because Grignard.
Become MgOH Br. Then plus the plus hydrogen. Yeah. R.
So this is actually polarized like this, MgBr plus. The moment it sees the water, it's so greedy that H plus will go there, OH will go there, this bond will break open. So when H goes there, what will it become? Simply hydrocarbon. This will become MgOH and Br. So the question is, what is Y? Y would be
C.
C. Clear? Both of you?
Yes, ma'am.
Enantiomers. Enantiomers are chemically similar. Their chemical reactivity is same. The melting point is same. Solubility is same. Everything same, excepting
Rotation of polarized light.
rotation of the polarized light. The enantiomeric pair, if you have one, what is enantiomers? What are enantiomers? Compounds, optical isomers, which are Mirror image forms of one another.
Non-essential.
Optical isomers. This is the definition. I told you, no. Don't go through that long 4-5 pages to get these information. Optical
Yes, ma'am.
isomers, which are mirror image forms, which are non-superimposable mirror image forms of one another, are called as enantiomers. One out of them is dextrorotatory, the other one is equally levorotatory. So their rotation of the polarized light is only going to differ. Okay, chlorobenzene is less reactive towards nucleophilic substitution.
True.
Very, very true. Nitro group of chlorobenzene increases the reactivity towards nucleophilic substitution.
Again, it's true.
True.
True, ma'am.
So both the R and assertion are true.
Ma'am, but
Okay.
then does the reason explain the A?
I think it's option B, ma'am. They are not related.
Yeah, it is. No, it increases the reactivity. Oh, yeah. Very much. Very much. Yeah. See, if the question had been nitrochlorobenzene is more reactive, then maybe you could have said, yes, correct. You are right. So this is right. This is right, but they are not connected, so it must be B. Both
Yes,
are
ma'am.
individually correct, but they are not connected. Okay.
Yes, ma'am.
The reaction given below, what is it called?
Wurtz-Fittig.
What's
Woods
fitting?
fitting. Okay, in Woods it is simply alkyl. In Fittig it is aryl. In Woods Fittig, aryl and alkyl join. Okay, racemization. What is racemization?
Equimolar.
When a equimolar mixture of enantiomeric pair.
Enantiomeric. Yes.
That's all. Equimolar mixture of D and L form of an optical compound, optically active compound. Okay. And racemic mixture. Racemic mixture is equimolar mixture of D and L form of optically active compound. Or in simple, equimolar mixture of enantiomers.
Yes, ma'am.
Simple
Ma'am.
definition. Okay. So where is it going to happen? Is it in SN1 or SN2?
SN1, ma'am.
SN1. Okay. So I will stop here and I will pass on this folder to the group. Go through this, and the advantage is that at the end of this group, like solution lesson, remember, the solutions will also be there.
Yes, ma'am.
Okay. And you will see lot of repetition. You will see lot of repetition in this.
Yes, ma'am.
Right? You will see. And answers are also there. So take the help of this folder also. I'll spend one more day for this. Until you become very, very thorough with the first lesson, you can rush through with the second, third, etc. Because you would have gotten the idea how to, again, recollect, how did you tackle the hydrocarbons last year? The same strategy is required here. Is it okay?
Yes, ma'am.
Yes, ma'am.
Yeah. Okay, ma'am. So I'll end the class and send this folder to you.
Okay, ma'am.
Okay.
Thank you, ma'am.
I actually had
Yes.
one doubt.
Tell me.
So when we do the SN2 and SN1